So this is the assignment which we have. It's basically a straightforward assignment in which we are required to model 1, 2, 3, 4, 5, 6, 7 weld preparation cuts basically. The 6 of them are related to plates, and the 7th one is a beam, kind of a rat hole, kind of a cut. So let's go into the details over here. So this one is a T type of connection, and it's a groove weld. It's a T type groove weld with one of the plates is coming in at a T to the other one. It's going to be a 45-degree angle cut. It's a 20 millimeter plate, and it's going to be a complete penetration joint. 18 millimeters will come like that, and then 2 millimeters, and there's a root gap of 2 millimeters as well. The second one, once again, is a T joint, a T groove joint, in which it's double-sided. The first one was single-sided. This one is double-sided. The third one is a corner joint. The difference being that this is partial penetration. As you can see, once again, 20 millimeter plates. The penetration is not all the way, it's 10 millimeters, and once again, it's 45 degrees. This one is a complete penetration joint with the J type preparation, 20 millimeter thickness over here, but the incoming plate is much thicker. And so the cut is going to be done like this with a 2 millimeter root cap over there. Then we have a butt weld situation in which, once again, it's a complete penetration joint, 20 millimeter thicknesses. One side, this type of weld preparation. Whereas in the other one, it's a 40 millimeter thickness plate. Once again, butt weld and complete penetration, and the details are given. The last one is this is the top flange of a beam and a column. The incoming beam is the top flange is going to be cut like this. This is usually called something maybe a rat hole, in which this is a complete penetration joint, double-sided, and all the distances are given over here. This is basically the exercise which we are required to do. So let's begin with the first one, which is basically a T joint with a one-sided weld preparation as shown, 20 millimeter plates. Let's go to the model. I've already created these 6 situations for the plates. So 2 T joints, 2 corner joints, and 2 butt joints, and then also the case of the top flange of the beam. So right now we'll just focus on this one. So when we want to create weld preparations, we can go to the detailing menu, and under the detailing menu you have this command over here called plate weld preparation. And if you click on the shift key and open it first, what we want is a one-sided weld in a 20 millimeter plate with 18 millimeters. So what we can say 18 over there and 2 remaining. And for this we choose this symbol, which is the one-sided weld, and for this one we choose this symbol. We don't need to enter the angle, it's 45 degrees by default. It's a T weld, so we apply. Okay, and then we just click on this button, and we basically just click on this edge over here, edge of the plate. And the moment we do that, let me right click and finish it and turn off the welds. You will see that if I look at it from the side, like that, you will see that the exact weld preparation has been made. There's a 2 millimeter gap over here. I can measure this distance over here. Actually, I didn't enter this distance, so let's undo that. Let's go back. Let's undo that and continue and do it again. We can go back into this command, press the shift key once again. These are okay, but the root face, this is the one I forgot to enter. We can enter it, that's 2 millimeters again. If you go back to the drawing, this is basically this distance of 2 millimeters away from the edge of the plate. So that's the one I had missed. Go back to the model. We've done the settings now. We just go in there again and just show this edge. And the moment we do it, once again, we can go look at it from the side. Click on this button to make it orthogonal. and now we can see that it's properly done. This distance is 2 millimeters, as well as this distance is also 2 millimeters. Now the next one is basically similar. It's just that it is double-sided, so we have the same weld on both sides. So instead of the 18 millimeters, we'll have 9 and 9 on both sides, and 2 will be left in the middle automatically. The same 45 degrees, the same 2 millimeter root face. So we go back to the model. We can go to this one over here now. Go back to our, click on the shift key, open this up. This time, because it's double-sided, we choose the same symbol for both sides. We make this 9 and we make this 9 as well. So 9 on both sides, and the 2 millimeter remains. Say apply OK. Click on the thing and just show any one of these edges. And when we do that, we can see that. Let's go and look at it from the side, that the weld has been created. The third one over here is not a full, not a complete penetration joint. It's a partial penetration joint, and it's a corner joint, and both the plates have been cut out. So this is a 20 millimeter plate, but it's partial penetration. So 10 millimeters have been cut out and 10 have been left. And also we note that there's no gap over here. So there was a 2 millimeter root gap over there, but there's no gap in this case. So we can go back to the model. This third case over here, go back to our command, press the shift key. So we want this case now, we want 10 and we want 10. So we want partial penetration like that. We want a root gap of 0. So this is the setting which we want, and we can say apply. Okay, and we can click on this button again, and we can select. So we don't know which edge we are selecting, whether it's the edge of the bottom plate or the other one, but it doesn't really matter because we'll need to do it twice anyways. We just select this edge, and we see that we've cut the top one, and now we can just continue and select the edge of the other one, and there we go. We have managed to create that partial penetration weld with no root gap over there. The next one over here is once again one-sided, and it's complete penetration, but it's a J-type preparation because it's a very thick plate, so it needs to go like that. It's full penetration, by the way, and 2 millimeter gap left on both sides. So we go back to the model, and we come over here, and this is the one we want. So we click on the shift key, open it up. And because it's a 30 millimeter plate now, and we want full penetration, so we'll call it 28. And instead of this symbol, we can choose this one to create the J-type penetration. And we need the 2 millimeter root cap as well. Now let's try it first. I think we'll need to change the angle because the default angle is 45. But let's press OK on that, and click on this one and click on this one, and we see that, let's look at it from the side, that it has done the cut in the J-style preparation, but it comes like that, and then there's an angle of 45 degrees, which is not what we want. We want it to go like that, and we want it to come straight out. So if that's what we want, then we'll just undo this, go back into the settings, and this time we put the angle input to be 0. Apply OK, go back inside, click on the edge once again, and this time you see that we managed to create that weld preparation as shown. This next one is a butt weld now. It's one-sided. It's complete penetration, 20 millimeter plate. So we need 18 and then 2 as shown. So what we will do is we will just go inside, go to the model. This is the plate ready for that. Click on the shift key. This time we select this symbol once again. We want 18 millimeters and 2. So we leave it like that. We'll leave the root and we'll leave the angle input empty as well. Root at 2 millimeters. Apply OK, and we can click on the command and just show this edge, and then whichever one it cuts, we just select the other edge as well, like that. So we see that we have managed to achieve the weld. Actually, now this one is actually 4 millimeters, so we should have actually inputted it to be 1 millimeter, because one is going to come from both sides. This last plate example is it's a thicker plate, 40 millimeters, so it's double-sided on both sides. Once again, the total distance is 2, so we'll keep the root at 1 millimeter, and 19 and 19 and whatever is left over there. So we go back to the model, click the shift key, open this one up, call this 19, and change this one to the other option, like that. So we cut it from both sides, and the root face we bring it to 1, like that. Click on it, select this edge, so we get, oh, I'm sorry, I think I made a mistake. Let's undo that. Let's press the shift key again. We need to do a two-sided one, but we need to make this one 19 as well. Yeah, sorry, that was a mistake. So 19, 19 from both sides, like that. Click on it, click on the key, so we go on that edge, so we get a double-sided one. Click on this edge, so we get another double-sided one. Look at it from the side. Click on this one, and you see now the total distance is 2 millimeters as required. Now, this final one, which we have over, over here, is not a plate cut, but it's an IPE 300 beam, and the top flange has been cut out with a double-sided weld preparation, and also this rat hole at the back side. And this is what we need to create. The distances, because the flange is 10.7 millimeters, so we've left 0.7 millimeters as far as the straight side is concerned, and 5 millimeters on both sides. And then this distance is given as 22, and this total distance is given as 17, and the gap between the column face and the beam is given as 2 millimeters. So just keep those numbers in mind. We go back to the model. This is basically the beam and the column. We just zoom in like that. And this time we're not going to use this plate weld preparation, but rather we're going to use this one, which is rat hole with the distance definition. So we just click on this beam icon over here, this rat hole icon over here. We select the beam, and then we show it this point over here. And when we do it, it creates a cut over there, which is a bit different from what we want, and therefore we need to explode this and modify it. But it gives us the basic structure. So let's select the cut, click on the M key, which will turn on the macro, and press enter. And we see our inputs are given over here. So we remember this one was 0.7 straight portion, and it was a 5 millimeter cut on both sides, so we can enter those numbers directly. Then we remember that the distance from the face was 2 millimeters, so that's given over here. Now, this distance vertically was given as 17, and this one was given as 22. Now, since this is 5 and this is 2, that's already 7, so I need to add another 15 to make this total 22. And to make the vertical one 17, the shape is different from, so there'll be an extra point, and that's why I'll need to explode it. But I need to give any two numbers over here, which make the total 17. So I can just say 2 and 15, for example. For this one, I need this total distance to be 22 as well. So since it's already 2 over here, we can enter 20 like that. If we do that and press OK, we will get the basic shape of 2 millimeter gap over here. 5 millimeters, 5 millimeters. This total distance will be, let's just measure it from here to here. It's 22 millimeters, and this vertical was given as 17. That's 17 millimeters. It's just that we don't have the rounding, because this one, if I turn on the handles, you will see that the macro by default introduces another point over here, which is not what I want. So obviously I can play around with this. What I can do with this is I can click on the M and right click and say explode, like that. And I can now select this cut, right click on it, and convert it into a polygon cut. And for that, it'll ask for which face do you want to be the definition. I'll keep the middle face to be the definition, like that. And now it's a polygon cut. And now what I can do is I can select this. This total is 17. I need a 15 millimeter chamfer, and since it's going to be exact over there, so I'll just select this and choose this type, and I can try 15 like that. Let's see what happens over there. Yeah, there we go. So that was basically the cut which we were looking for. We've got all the dimensions according to what the requirement over here was. It's a rounded cut now. We could have used the other one as well. Both can work, but since this is the assignment, we've gone the extra mile to make sure everything is exactly the way it was asked for.